Okay, so just a couple examples that we did not get to in class today. This one got ugly pretty quickly, and we were running out of time, so I want to finish it here. I'll restart it from the beginning. But just first and foremost, wrapping our head around what's going on here. We have customers purchasing a computer. Of the 100% that are definitely purchasing a computer, 68% of them are purchasing type 1 and 32% of them are purchasing type 2. Then this is what we have to read carefully as well. Percent of those who purchased that also purchased a warranty. So of these people, 35% of those people also purchased a warranty, which means 65% of them did not. And of these people, 56% of these people purchased a warranty, and then the rest did not. So I'm not sure a Venn diagram is necessarily the best way to go about this. I almost think making up a random number of customers might be the best way. So let's say we have 100 customers, because 100 is an easy number to keep track of. Of those 100 customers, 68%, which would be 68 people, got type 1, and 32% bought type 2. Okay? And now here's the reason I did this way, because now we're going to break down that 68 into who got a warranty versus who did not get a warranty. So this here tells us that 35% of those 68 people. So on a calculator, 35%, 0.35 of means multiplication, 68 gives us 23.8 people. Now, I know that you really can't technically have a decimal number of people, but because I made up this number, I kind of run the risk of that happening. So 23.8, hypothetically, of those 68 would be 35% of those 68 bought the warranty, which means the rest did not. So the 68 people minus the 23.8 who did buy the warranty leaves 44.2 people who did not buy the warranty. And a similar breakdown is going to happen under type 2, because this is saying that 56% of these people, so again, warranty and no warranty, so if there's 32 people that bought type 2, 56% of them bought a warranty. So 56% of means multiplication, the 32 type 2 people, 17.92 bought a warranty, which means the rest did not. So 32 minus 17.92 people leaves us with the remaining 14.08 who did not. So that just helps me really wrap my head around what the heck is going on here. And then I can look at the question. If a customer was chosen at random, what is the probability that they did not purchase a warranty? So of our 100 total people, this many and this many did not purchase a warranty. So add those up, 44.2 plus 14.8 out of the 100 people. 44.2 plus 14.08 gives us 58.28 out of 100. So that's 0.5828, and that's our 58% did not purchase a warranty, and your probability is the decimal, so 0.5828. So again, tricky, and it's the reading, and I don't know how else to tell you this, but I'm not going to be able to predict, and the Common Core is kind of done this way. We're not going to be able to predict all the different ways that a question is going to be asked. The best we can do is expose you to these difficult reading type questions and give you practice trying to figure out how you would do this on your own and make sense of it, and then model for you the thought process, and hope that kind of trial and error process is going to help you learn how to be independent thinkers. The bottom section here is a little more straightforward. When we're asking for how many ways something can happen, I'm not sure how this could come up, but I could see it being helpful in some certain ways, because obviously you could list all the different possibilities. But if you're playing 4 baseball games, and how many ways can you win 2? You'd almost have to do a tree diagram, which I'll do down here and then I'll erase because it's not going to be the most efficient way. But in your first baseball game, you win or lose. Then you're going to play your second baseball game, which you're going to win or lose. Then off of those, you're going to play your third baseball game, in which you'll win or lose. And then we have one more baseball game to play off of each of those. Which, again, tree diagrams get ugly very quickly, so they're not efficient. But we're going to use this one to see our answer, and then I'll show you the shortcut. So now we got to go through all of these pathways and see how many are exactly 2 wins when we win 2. So here's 4 wins. Here's at least 3 wins, so that's no good. Here's win-win, loss, W. That's a 3-win. So win-win, loss, loss. That's 1. With exactly 2 wins. If we go win-loss, win-win, that's 3 wins. Win-loss, win-loss, that's good for 2 wins. Win-loss, loss, win, that's good for 2 wins. And win-loss, loss, loss. Loss, win, 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 that's too many wins. Loss, win, win, loss, that's 1. That's 2 wins. Loss, win, loss, win, that counts. Loss, win, loss, loss. And then we got loss, loss, win, win. That's 2 wins. And then loss, loss, win, loss. Loss, 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 win. Loss, 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 loss. So 1, 2, 3, 4, 5, 6. It ended up being 6. Okay? But that was not efficient. So when you're looking for the shortcut for in how many ways, on your calculator you have a whole probability menu. If you hit the math key, up here at the top is PRB for probability. If you go over there, this is permutations and this is combinations. Okay? Permutations is when order matters. And in this case, we don't care the order in which we win the 2 games, we just care that we win 2 ways, and so we would use combinations where order does not matter. So the N stands for the number of trials total, and we have 4 trials here because we're playing 4 games, and we're looking for 2 wins. Okay? So we would do 4C2. Before we do that, we have to hit the 4. Then go to your math and your probability, and then you choose 2. And it's going to give us our 6 ways. And it's going to give you your total number of ways. So, a couple notes to take. We have combinations, where order does not matter. And we would use NCR. And permutations, where order does matter. So you would specifically want for something like that, win the first 2 and lose the second 2. That would be a permutation and PR. But for now, this is 4C2, and we get 6, which is a much, much quicker way than the tree diagram. So I'm going to get rid of that. Okay, on any given day, it either rains at some point or doesn't rain. In the span of 7 days, in how many ways could it rain 3 days? Okay, so we don't care what 3 days, we just care that it rains 3 days. So that would be 7, choose 3. 7 with a combination of 3. So we would type in 7, go to your math, over to your probability menu, 3, so we're choosing 3. And there's 35 ways that can happen, which I'm glad we have this shortcut because now what this is going to do in most cases is going to help you find the denominator of a probability question. So now if they asked you the probability that it rains specifically, how could they ask you this? They'd have to ask you something like, what's the probability that it's going to rain, if it's going to rain three days, what's the probability that would happen the first or the second day? So it would be, you know, something out of 35. But I'm not sure we'll go that far, but we're just going to try to kind of quicken up the tree diagram approach. And on a 10-question multiple choice test, in how many ways can you get exactly 8 right? That would be a 10, choose 8. And how many ways can you get exactly 9 right? That would be 10, choose 9. And how many ways can you get exactly 10 right? Well, that logically we should be able to come up with. If there's 10 questions, and how many ways can you get all 10 right? Well, it'd have to be right, they'd all have to be right. There's only one way to do that. Versus, how many ways can you get exactly 9 right? You could get the first 9 right. 1, 2, 3, 4, 5, 6, 7, 8, 9. You could get, and then the last one wrong. You could get the first one wrong and the rest right. And you could really kind of scatter that one wrong anywhere. So you're going to see probably 10 different ways that can happen. If I check that, 10, 3, so 10, choose 9. There's 10 ways that can happen. That's really because your one wrong can be scattered into 10 different spots. So there's 10 ways that can happen. But the only way to get 10 right is just to do right 10 times. And so this should be 1. And you'll see 10. How many ways are there to choose 10? There's only one way to choose 10 if you only have 10 choices. So sure enough, that was 1. Okay, now at least 8 right. Well, the probability of getting exactly 8 right, or not the probability, but the number of ways you can get exactly 8 right, but at least 8 means we also need to look at the probability, or the number of ways that we can get exactly 9 right, and we also need to look at the number of ways to get exactly 10 right. And if there are 10C8, there's 45 ways to get exactly 8 right, 45 ways. There were 10 ways to get exactly 9 right, and there's 1 way to get exactly 10 right. Means there are 56 ways of getting at least 8, because you got these ways and these ways and these ways all added together. So just a little shortcut to figure out in how many ways something is possible. And that's your combination.